The next thing we're doing is switching fundamentals. So let's just talk about how networks work and the fundamentals of switching. So I'm going to use a couple of boards here. The first thing I'm going to do is just show you physically how we might put a network in a building. And for the people who came from the voice world, you're going to like hearing this. Data people stole everything from voice people. They did. They did. They stole everything. Because why? Why did they do that? Voice was around for 70 years before data was even thought of. Yeah. So our wiring, the way we wire things, the way we just changed a few names and everything, but in essence, the way data is deployed today is the way voice was deployed for years. For years. So in an organization, a building, if I have multiple floors on a building, again, I'll have PCs out here on the edge, the access, people who want to access the network, mobile devices, whatever they are, through access points and all that. We have to connect them up to access the network. So we have to have a series of switches that we'll talk about that are called access switches. Access switches. Switches to access the network. And they're the ones that you actually physical cable or where our access points connect up to. Now these have changed. The roles of these switches have changed. When Cisco first started acquiring switching back in the 80s, or the mid-90s, everybody used a copper cable. There wasn't any wireless. So one PC, one printer, they took a port up in here. They took a port up. So you connect a wire out to the cubes and everything, and you hook the cable in there, and that's how you access the network. No other requirements other than you connect it up to an Ethernet network. These switches that access the network come in, you can get them in 24 or 48 port densities. So they'll have 24 holes or 48 holes to connect users up into. That's about it. Access switches. We'll talk about the products a little bit later. We'll go online and look at those after we get through the technology part. These will be connected up down here where all of our users, so every floor will have an access switch. Every floor, yes. Yes, sir.
What is the representation of that?
All right, this is a building. This is a building with 3 independent floors. That's the representation. Each one of these, so there'll be a locked room somewhere called an IDF, Intermediate Distribution Frame, a term that we actually got from Voice World, and all that. That's where all our wiring goes to. So in my cubes out here, I'll have a little, in each cube, I'll have a little panel, I'll have a jack number and everything, and it goes back to a room that's locked, and we'll hook these things up, these switches up there. And then these switches will actually connect to bigger switches. Switches that live down here called distribution switches. U-T-I-O-N, distribution. A distribution switch, a bigger switch, generally going to be connected up through fiber optics. Fiber optic cabling. Now, why would we use fiber optic cabling? Yeah. So we may need more bandwidth? Maybe just distance. Might be the distance. Copper only goes 100 meters. 328 feet is the limit of copper. Think about it. If I'm going from the front end of this room to the back end of this room, just to go maybe 45 feet, I put a jack down here at the bottom, I've got to go 16 feet straight up just to get someplace where I can start going that way. So I've ruined 16 feet of copper. I start going, oh, there's a sprinkler. I gotta go over here. There's a light pole. I gotta go over here. You might use 90 feet of cable just to go really linear, as a crow would fly, over here, 40 feet. So I use that up really quickly. And I might want to do faster speeds where this is gigabit Ethernet. Might want to do something faster. Let's think about it. I've got 48 users coming in here at gigabit Ethernet or more. And they're all trying to get to the same resources where my servers are at somewhere. So this has got to be a faster pipe. And I can replace the ends, but I certainly don't want to have to run new cables all the time, so I put fiber optics in there. So distance and speed make a difference between all these connections. And then, if I have this building, I might have inside of here a data center. And we have specialized switching inside the data center, and this is where our applications are at. And they'll connect up perhaps to the distribution switch. So it's equal. So somebody setting here goes access distribution data center. Somebody setting here, access distribution data center. What if I have multiple buildings? What if it's a campus environment? I put another building up here. This is a new building. What do? A cookie cutter. I just take this cookie cutter and put it over here. So I just put an access switch on every floor, a distribution switch here. I connect these guys up, and then I connect the distribution switches together in a switch that I'll call a core set of switches. And then I hook my data center into that. I can scale this tremendously. This is how Cisco, and again, this isn't rocket science, it's logic. It's how we want the network to be fair to everyone. So when we start talking about switches this afternoon and we go online, I'm going to say the Catalyst 2960 series is an access switch. The Catalyst 4500 could either be an access switch, or a distribution switch, where its role could play inside of a network, depending on the size of the network and the requirement of the customer. Does that make sense? It's just logical. It's just a logical thing. You can grow these. So in every one of these buildings you see on Cisco's campus, they've got access switches on every floor. They'll have a distribution switch in every collecting all the information, and they'll run it to core switches on our 3 parts of our campus, because they've got really 3 campuses here in San Jose. And you can cookie cutter that and be fair to everybody and give everybody equal access. And I can engineer that network easily. Same person sitting here and the same person sitting here have the exact same capabilities and to get to the applications that they want the same way. Same amount of hops. It's fairness. It's what we want on a network in a perfect world. In a perfect world. Does that make sense? Yeah. So when we talk about our switches, we'll talk about that. Now, what are some of the requirements for switching that has changed in the last few years? The last 10 years, 15 years. Excuse me? Somebody say anything? Density, maybe. Speed? Speed, obviously. I can remember when we first, Ethernet used to be 10 megabits. And then it was 100 megabits. And then it became switched. Once we got switching in there, I used to say, I hooked up a network for a customer. It was 100 megabit switch to the desktop. And when I walked out of there, I said, that customer will never use that much bandwidth. Ever. No way. I'll be dead by the time they use that much bandwidth. Well, tells you how smart I am. I told you I wasn't the sharpest knife in the drawer. But really, if you think, we've continued to drive these bandwidth demands, right? What are some of the things that have driven changes in switching? So now we connect access points. Now the first access points that we connected up there. Now, what were the, even before access points, what do you think about IP telephony? Voice. IP voice. There's pretty little IP phones. One like hanging on the back wall. You notice it's got one cable connecting up to it. One cable. How does it get its power? From the switch. It's totally different than the phone, the PBX. The PBX actually was copper connected all the way to the phone, and it provided all the electricity. All of a sudden, when Cisco said, we want to put voice on a data network and we want to make hook those phones up, what was the requirement that changed switching? You have to do power over Ethernet. Was there a standard for that at the time? No, not at all. Not at all. Matter of fact, when Cisco acquired Celsius, the company that gave us our communications manager, what we call communications manager today, it was called call manager then. But when we got that device, that application and everything, first of all, we had ugly phones. But second of all, we had a new requirement for the switches, and there was no standard for it. So early on, Cisco created a whole new line of switches at the time, the Catalyst 3550 switches, that did a pre-standard version of Power over Ethernet. Why? Because customers are not going to use these pretty little power bricks on their phones and their cubes. It wasn't done before, and they're not going to do it now. So the devices that we put out here, if we put an IP phone out here, now we have to do Power over Ethernet. We have to power that thing somewhat. So what Cisco did is, knowing that they developed a switch that would provide that. Now the first power was called inline power. It gave about a little less than 8 watts of power for the phone. That was pretty cool. And it took the industry about 22, 23 months to come up with a standard. Standards are hard to get here. It takes time. Cisco did not want that time to surpass. You lose a lot of margin. You lose your value in 22 months. So what Cisco did is came out with a whole line of switches that did pre-standard Power over Ethernet. Pre-standard. And then when the standard came out, 802.3 AF, PoE as we call it, the standard, became a standard. What did Cisco do? Within 30 days, they came out with a whole new line of switches that did the old way and the new way. So we were driving this. Cisco was driving this capability. And then access points. People said, hey, now we can power access points. Early on, I've seen wireless a lot of times. I had a customer one time when Cisco first acquired AirNet. I went into a customer and he wanted to do wireless. We were pushing him on wireless. And he said, yeah, let's think about doing that. This was before Power over Ethernet. And he had a pretty big facility and everything, and he was going to buy, I think it was $19,000 worth of access points. And it was going to cost him $27,000 to run electricity to where we needed to put them. And you know what he said? I ain't doing it. I ain't going to do that. He had to get his electricians out and his contractors to run electricity so we could run an outlet near that access point. So guess what? With Power over Ethernet now, now we could put access points and power them anywhere. So the cost of that technology actually dropped down, and the use of that technology opened up, which was good for Cisco because they were selling the stuff. So access points use Power over Ethernet. Pretty soon we wanted to put 2 radios in there. We wanted our phones to have color screens and do all this cool stuff. We needed more power because this only gave us about a little over 15 watts of power. Couldn't do everything you wanted to on the phones. So we needed more. So Cisco did pre-standard PoE plus. Cisco came out with a line of switches. Again, their line of switches actually gave more power, about 22 watts of power. So you could actually have 2 radios in the access points until the standard. Again, 20-some months later, the PoE plus standard came out. And Cisco has a line of switches that do all that PoE plus standards now. The switches you sell today can give up to 30 watts of power across all that, so you can drive all these pretty little devices. What about video? What about VXI, virtualization, all these other things? The demand for power at the edge is starting to become greater and greater. I want to have a device that I can actually have video, a nice monitor, and actually do that. That's kind of cool. That's going to require more than 30 watts of power. So Cisco is the first switching vendor to be able to provide UPoE, which is 60 watts of power, to devices at the end. Is there a standard for that? Absolutely not. Not yet. There will be. But in our Catalyst 4500, we can actually do that today. We can do that today. Why is that important? Because you might have a device out there that you want to do that. Now, because we're hooking up these devices, these phones and all that, with power, it becomes an interesting thing about where IT's at. IT had to, a lot of times, add more power capabilities in their wiring closets, cool them down a little bit more because they weren't designed for that. But now that we're hooking up these devices and powering across, wouldn't it be nice to be able to turn those devices off? You took 27 hours, you said, door to door? 32 hours door to door? Did you guys leave all your televisions on and all your lights on in your house? Would you do that if you were the only one living there? Huh? No, you want to turn this stuff off. Why would you want to turn these devices off? How many people just leave their house with all the lights on, all the heat turned up, and or air conditioning, depending on where you're at this time of year? All that. What do you want? You turn it off. Why? Save money. Yeah. Wouldn't it be nice to be able to do that? To measure that power and to turn it on and off at your whim, even in this? Wouldn't that be cool? Yeah. Well, Cisco, again, has inside of our switches, inside the iOS, inside the physical capabilities of the switch, we have something called EnergyWise. EnergyWise is the capability to measure, not only measure how much power an individual device is drawing, but monitor it and turn it off. Think about a bank. If you go into a bank and they had IP phones everywhere, banks operate from, let's say, 8 o'clock till 5 o'clock most days, and then everybody goes home. On weekends, most of them are not open, right? Certainly on Sundays they're not here in the U.S., right? You got all these devices. Half the time, you don't even need power to the phones. What if we could turn them off? Wouldn't that be cool? We have those capabilities in there. Customers can save 30% of the cost of the switch over a 3-year period, in a lot of cases, just turning it off and off and measuring that. So the capabilities of our switching products to work back with our EnergyWise servers to be able to turn that on and off. So in theory, Eddie's cube is on the 4th floor here. The lights are all turned off on the 4th floor. Eddie always gets in early because he tries to get out of his house as early as possible because his daughters are going to get up and raise Cain. And so Eddie comes in, he uses this one application, right? His access card application. So he clicks the access card application and it says Eddie's allowed to go inside. Eddie's assigned to a cube over here. He's signed up for a cube over here. He's got a cube over here. Guess what? He could actually turn the lights on the 4th floor electricity-wise because Eddie's coming up. And he can also turn Eddie's phone on. So those other 23 hours, 22 hours or whatever it is that Eddie wasn't using, there was no draw on the phone. Would that save a customer money? Yeah. That's where we're going at. Now, here's the big question. Does IT care about that? Huh? CFO does. But why doesn't IT care?
Their job is to just ensure the lights are on.
Exactly. They don't even care about the lights, right? They just care about the PCs. It's the same thing about Emily. Emily doesn't care. So I'll go back to the fundamentals of human nature. My daughter Emily likes to watch that CSI stuff. You guys know CSI, all these murders that are happening and they solve them through all this stuff. You know, it gets kind of gruesome and all this, that, and the other. But she likes it. But she gets scared. So on the weekends, Friday night, Saturday night, when she stays up, she says, can I stay up? Absolutely. She'll have her own little CSI thing, and she'll stay up till 1 or 2 o'clock in the morning watching all these CSIs. And then guess what? It's time to go to bed, and she's downstairs. Her bedroom's upstairs. She turns off a light switch, it turns dark. Do you think she turns them off? I wake up at 5 o'clock in the morning, and every light in the house is on. Why? Because Emily's scared. It gets dark when the lights go out. Yeah, exactly. Yeah. But she doesn't have to pay for it. Emily, turn out the lights. Turn out the lights. Turn the heat down. Do that. Save me some money. But she doesn't pay. This is a way for us to be able to do that. Is this a differentiator for us? Absolutely. But who cares about it? Not IT. Do you think IT is going to the CFO and saying, hey, we can... Probably not. They should. In the perfect world, they should, but they can't. They can't. We can measure them on. If IT was smart, they'd take this over and actually start charging back to the business units. You've got a sales organization who's set in those cubes over there. Guess what? I'm going to charge you back for your electricity. I'm already charging you for your PCs and internet access and all this, that, and the other. Now I could charge you for your electricity if they would do it. But they don't.
Are you saying that we have that IT's buying it for whatever, $100, and they're not using that feature?
That feature is in every switch free.
They're not
They're not turning it on because they're not going to the business and saying we can save ourselves more money. They don't see the value in that. They're not doing it. Very, very few times do they even know about this.
The large enterprises are finding ways of charging back the business for data center usage. That virtualization, how much usage are you using, R&D, et cetera. Take a look at NetApp and what they're doing. They're absolutely doing that and having the business pay for usage and power and pushing all that back into, with CFOs now monitoring how much expense and where those expenses go. There's a change taking place, having been at IBM for the last 11 years in consulting. There's a huge change, at least at the big enterprise.
Big enterprise.
Yeah.
Big enterprise.
But that's trickle down.
I think in the smaller space, I work in the geo space, which is tiny, so I have.
That might be a
about
completely
5.
different world.
Yeah.
So for you,
But the enterprise
I
is-
was an enterprise when I was at the bar, so I understand you're exactly right. But it's hard to get a smaller customer to believe in that because you have 1 or 2 people in IT and they're doing everything.
They're doing everything.
They're the application
Right.
side, they're in database management.
Absolutely.
So they can't see that because honestly, they don't have time, they don't get paid enough.
Right.
So it's hard to get that message across to smaller customers, but you're exactly right, larger customers are seeing it because they see the impact, right? They
Absolutely.
you can do the ROI tool and you can show it to
They
them.
could never. It's
Okay,
something we
I
could
actually
never
built
do
my
before,
dollars.
but now we can. Let's use it across the board. I'm just saying the availability is there
Yeah.
to take what they've already done in that data center. They've already done that in the data center. Now I can take that to the branches. So think about it. If I've got 40 branch offices, I can actually start making a difference at those branches. So how do we have to bring that up? Hey, the cost of the Cisco switch is this, right? We're so expensive. But if you do this across 40 different branch offices and things, the cost of that switch over the lifetime of it, you're going to save $3,000 to $5,000 at least on that switch. So we have to talk about this. We're going to have to talk about this. We have a whole calculator to figure it out for you, how much you'd save, what devices you'd have, and all that out there to do this. We just have to get it out there. Yes, sir.
Eddie, do we monitor, through the switch diagram or anything, where those features are turned on?
Could you say that one more time?
Can we monitor remotely?
Remotely, absolutely. Could we monitor remotely? Absolutely. I could go to every switch and tell how much power is being drawn by any port and what MAC address is associated with that.
Sorry, as Cisco, do we keep records of what features are turned on our customers' switches?
No. No, we do not. We do not. No, the individual SEs may know, but we do not go into a customer's switches, networks, and do that and pull it out. No. That is something the customer wouldn't want us to do.
The
I
capabilities.
disagree.
No, yeah, you
Yeah.
disagree correctly because we actually, for remote managed services, can actually monitor networks, monitor equipment, confirm when issues take place, can pull out information.
With
I don't know how much
customer-
of that information, but we certainly.
So I disagree that customers wouldn't want us to do it. Some might not, but
Yeah.
some wouldn't have an opinion.
I would tell you this. I would rather not have Cisco do it. Like to have my integrator do it. I don't want Cisco to do it. Because they're not my integrator. They don't install it. Does Cisco install our switches? How many switches did our SEs install this year? None.
It's a service.
It's a partner-driven model.
Partner-driven.
It's a partner-driven model.
So Eddie, thinking of NetApp, right?
Yeah.
Which was mentioned before, so I used to work at NetApp. They have a portal that they provide for the customer, so every device that's under a maintenance contract, you can dial in, you can have a look at how much consumption of that device, what licenses you've got, and what features are being utilised on a portal that's just a free part of the service contract that you have. So I guess.
Could Cisco do that? Yes, it's part of our advanced services. We could certainly do that if we wanted to, if they wanted to go to Cisco. But again, what's the cost difference between us doing it and maybe some of our partners doing it? Yeah.
You've got it in one place, I mean, it's great for us, right? 'Cause that's-
Absolutely. I'm not saying we can't. I'm just saying, if I'm a customer, if I've got advanced services and Cisco's doing absolutely everything for me, yes, Cisco would do it. But if I go to an integrator, I go to a gold partner who's doing the installation and doing my second tier support or whatever it is and all that, I want them to do it. Now, we give them the capabilities. Our switches will do anything but cook your breakfast and wash your dishes with the features we've got. It's just when you want to turn them on and everything. But as a customer, do I want Cisco to be able to come into my network without my permission and look at what features I've got so they can come in there and sell it to me? Absolutely not.
Might just be the switch sending information out rather than Cisco coming in and doing it.
There's a lot of what we call layer 8, 9, and 10 with that. Because
there was a feature when I was wearing Zoom before. There was a feature to have the devices phone home and provide some data for analytics and troubleshooting, so that help the tech raise more awareness and.
Absolutely, and Cisco's got phone home features. Again, it's some of the things we learned in the data center world when we first got in there with our MDS 9500, where if something fails, you can have our switches call and open up a ticket with TAC or whoever you want to. Yeah, that's great, and that's good. We want that. But again, we don't want to be able to dive into a customer's network from a customer perspective without my permission, you diving in there and doing that.
Yeah, no, I want to
Yeah,
that.
but you'd want it,
Sending
yeah,
data
exactly,
out, so
yeah.
This is how I'm configured.
Yeah, but
every week or every month.
yeah, absolutely. Well, we have that with updates with some of our security products, right? Our IPS, new signatures for things.
This with Prime as well.
Yeah, and Prime will actually do it as well. Absolutely. It'll actually go out and get the latest version of security, threats, all this, that, and the other. We have those services. It can do that. But to actually go in and tell you what features you're not using to go back and sell, I'd love to have that if I was an SE or an account manager. But that customer says, how'd you figure this out? That'd probably drive them to another vendor in some cases. Yeah. Yeah. So the capabilities are there. Folks, we have more capabilities in our switches than anybody else, trust me. And there's literally, you'd have to come up with some crazy scenarios of things we couldn't do. But what customers will accept is different.
Is there a flip side to it? I mean, I'm saying, the IT may not want to use it, but it's not only because they are not rational human beings, right?
Mm-hmm.
Is there a flip side? I mean, do you need to, compromise on something else? Or?
It does. It's a feature that's all you have to do is turn it on. There's no performance issue. There's nothing on that. There's no performance issue at all turning this on and off.
I mean, the CIO would be more than interested. Let's say the normal IT guys are not for.
Oh, CIO would certainly be interested in this. Yeah, because it would show him more value, right? He's getting closer to the business and helping the business. It'd be nice if he was already just upgraded his data center. Again, those 3 architectures. What if he just went in there and did that with his data center so now he can measure all of his applications and all that there? Wouldn't it be nice for us to walk in and say, hey, by the way, our borderless networking now can attach to that. You can now start measuring everything at the edge. At the edge. That's those 3 architectures, folks. That's how they work together. And again, this is unique. So again, we have energy-wise features in all of our switches inside of these. Now, what are some of the other capabilities, some of the things that have changed on the network since 2000? Management, yeah. So let's just talk about management. Let's just talk about the applications that are on the network today. Back in when the switches first were born, back in the early mid-90s, Cisco acquired switching and everything was data only. It was data only. Then we put voice on there. How many people here were voice people? How many people were voice people? The PBX voice people? Yeah. It was easy to troubleshoot voice, wasn't it? You follow the wire. You really had to follow a wire because that's how you figured out the phone wasn't working. You had to send somebody to do the cut down tool and move all that, and now we don't have to do that. But think about how you troubleshoot a phone call or a video call today. How do you tell if a video call, what if you've got your CFO is going to have, you're in one theater and your CEO's in another theater, and every Tuesday, first Tuesday of the month, you have these video calls that are going to happen. And they're going to be really important because the people on the end, if they don't get the quality video they expect, it's going to look really bad on IT. How would you like to be able to manage and troubleshoot that? Well, Cisco's actually got this technologies that they've been baking into our networks, our routers and our switches for several years now. MediaNet. Well, what the heck is MediaNet? Well, for early on, for the first year or so, I used to call it the Easter Bunny, the Tooth Fairy, and Santa Claus. You heard a lot about them, but you never really saw them, right? But what if I gave you the capabilities in an individual switchboard? So let's say that you get one of these nice video devices, MX200. Nice screen, great codec. Man, it's really cool. And you're going to hook that thing up. Wouldn't you want the switch to know what the device is? Wouldn't you like to easily deploy that? Well, guess what? On our codecs, we put an MSI or software in it that identifies it and the flow of information, video flow of information, and we actually make our switch ports aware of that MSI. So it can actually see the flow of information that your codec's using. Who's logged in there? Who's actually making this call? Where these flows of information are coming? It knows to put it in a specific VLAN, going to this specific communications manager. We put QoS capabilities on it and everything, and we can monitor everything that happens there. We can actually see packet loss, jitter, all the things that ruin video. We can actually measure it at every point along the way with this capability, MediaNet. So if you got a video call from this to over here, and you've got another MX over here, I can actually track that all the way through and see at every point that's MediaNet enabled, every router and every switch, what the flow is, so it's easy to troubleshoot. Wow. It's almost impossible to do without that. And guess what? If I have my CFO over here and he's doing any call to anybody, I could actually, through Cisco Prime, our network management, set it up to where this switch here will send a test call 3 to 5 minutes before through the network to the other switchboard on the far end and measure it and see if it's going to work before that call happens. So when the call happens, it does happen. So I can at least troubleshoot it before. Wouldn't that be cool? That's MediaNet. Now again, MediaNet's got a bad name for a lot of people because again, we heard they started talking about it before they had anything to talk about. Now they got this to talk about. Who cares? Who should care about that? The business for sure, but the IT for sure. I think this is one place IT should be doing cartwheels for this. Yeah, they should be doing cartwheels for this. You know, what if I have a branch office and I just want to say, we got to roll out video to the branch office in San Francisco up there. I wonder how video is going to work inside of there. I could actually go to the local router and have it stream about 70 meg worth of video just to see how the network works with it. If there's bottlenecks or something that doesn't work right. Before I even send a technician, I can actually see that. So baked into our switches and routers is this capability called MediaNet that we can unlock with our network management called Cisco Prime. That's the only way to unlock it. But the features are in our switches and routers. The features are in those.
Are these fee-based features or they're free?
Huh?
Are these fee-based?
No, they're free. They're baked into our iOS. They're free. You just got to turn them on. You got to have a certain level maybe of software on these devices. You probably have to have instead of a 2900 a 3500. But minimal cost for the value of this. For the value of this. Yes, sir. Yes, Prime is a network management piece that we'll talk about a little bit later. Yeah, it's a software application that unlocks that. That's important. Now, how can we make that relevant? Again, the architecture matters only when it matters. How can you make that important to business leaders? So I go to you, Vice President of Sales, and I say, I want you to start using video for some of your bigger sales teams and sales calls and sales leaders with your customers. Wouldn't that be important to you? Because your reputation's on the line for how this works. Yeah. For IT, it should be just troubleshooting and being able to manage this. Be careful what you ask for. When you say we're making video as easy as making a phone call, this is what you're going to get. And that MSI is going to make a big, we're putting that in all of our endpoints, all of our software endpoints, all of our hardware endpoints, all of that so we can actually troubleshoot flows of video through the network, because without it, you're going to be lost. I can tell you that. You will be lost. There's no following wires here. You can't do that. We're actually putting it in our WebEx clients and all this, that, and the other as well. So you can actually have track individual people in a WebEx call. That's important. And it's all features built into our switches and routers, and our switching. Do you think this is important to your customer? You think this? Again, there's a reason that Cisco's expensive. It used to be that we build our own chips, our own ASICs, what we'll talk about later, but these are some of the things I think are really relevant today for business leaders and people to think about in our switches, at least. Determining on which switch you want and why you would want it. But let's just talk about how a switch works in the first place. Let's just talk about the fundamentals of switching. And again, we talk about virtualization in a data center and all this, that, and the other. Well, virtualization actually happened a lot earlier. Happened in the mainframe world and actually has been done in switches for years and years and years. So let's just talk about how a switch works. And then we'll actually get into the products themselves. So up here I've got a very simple network. I've got 2 PCs on one network, and I have another network up here, both separated by a router. And again, a router's job is to separate 2 different networks. This is the 10-10-10 network. This is the 11-11-11 network. Very simplistic, and again, we don't need to, complicate anything here, just to look at the fundamentals of what a switch does. A switch is fundamentally, it's a traffic organizer. The job of a switch, everybody's heard of a hub, and a hub is nothing more, it's about as smart as this wire right here. That's how smart a hub is. It just all it did was give us a few lights and gave us electrical connections. When one user on a network sent out a frame, everybody got it. Matter of fact, the hub sometimes would send it back to the person who actually sent it, so they actually got their own information. So it wasn't that smart. Switches were the first place where we could put intelligence in the network closer to the user. We'd had routers before, but now we were pushing intelligence back there. And the intelligence inside of a switch actually comes from a chip in there called an ASIC. An ASIC, an application-specific integrated circuit. It's a chip. And that chip can be, you can buy these chips for Ethernet switches. It's what a lot of our competitors do. They buy these chips. And the chips that they buy have everything that is a standard. Everything that you would do as a standard in that chip probably 3 or 4 days before they were stamped out. Before they went through their run to create millions and millions and millions of these chips. That's not the Cisco way. Cisco actually designs their own ASICs. Cisco actually designs their own chips. So that's why we are a unique software and hardware platform. We spend millions and millions of dollars in R&D on just our chips, on just the chips that we use inside of our devices. That's the premium of our product. What?
Juniper does the same thing. It just depends on the networking company.
I agree that Juniper does the same thing, but again, what's Juniper's market share? That's all I'm saying.
I'm just saying,
Yeah.
when we're talking about ASICs and companies and such, I've lived the ASIC world for 20 years. So.
No, I'll just tell you, in the switching business, the difference between a Cisco and an HP switch is, where's the price? The price difference. The difference between a Cisco and a Juniper switch, where's the difference? Huh? The capability and the technology, and it's all in our chips. What do we do in R&D? How much percentage do we do in R&D for Cisco? 15, mid-teens percent, yeah, mid-teens across the board. We spend an excessive amount of money, what a lot of people consider excessive amount in R&D. Why? Why do we do that? It's a differentiator of us, exactly. As a matter of fact, Cisco was acquiring all these companies back in the mid-90s. You were selling to them, and yeah. But we were acquiring these companies and trying to fold all these features and everything. And eventually, Cisco just bought a company that built their own ASICs. Yeah, yeah,
I lived that night
yeah,
here.
yeah,
It was incredible.
yeah. Absolutely, had to be the best place to be selling, right? When there's a war, you want to sell bullets, right? That's what you want to do. But Cisco's ASIC, so it's a differentiator because that tied with our iOS makes these things different. So let me give you an example. It'll take me a while to get here. This ASIC is where it keeps, Switch has nothing but a spreadsheet. Now I know there's some people in here from Oracle. That's a big spreadsheet. We're talking about something simplistic. Inside of the Switch, there's a CAM table, Content Addressable Memory Table. That's what's in it. What makes the PCs unique is their MAC address. So when a PC connects up to a switch, the first frame it sends through there, all of a sudden this switch says, I've got somebody connected up to me, and they've got a unique MAC address. So what they do is they put them in their spreadsheet. The spreadsheet says the port number that we see them on and the MAC address associated with that port number. So in this case, this switch sees MAC address A on port number 4. Port 4, MAC address A. And it says, let's say this is port 6. On port 6, it sees MAC address B. So all it does is keep up with all that information. It keeps up with that. This switch up here will actually see, I guess I better give it a MAC address. MAC address C is going to be in this CAM table. Again, some of these CAM tables can be excessive. Some of our switches can know up to 128,000 different MAC addresses. Huge amount of MAC addresses. Matter of fact, that's a good attack on a switch. On a switch, you can actually attack a switch by flooding it, having a PC connect up and just throw more MAC addresses in it than it could handle in its buffer. Next thing it knows, it forgets about everybody it knew about because it's first in, first out. Cisco switches, by default, actually won't, you can't do that. They actually stop that. If you see a flood of MAC addresses, it would say somebody's attacking us. We're not going to believe those are real MAC addresses. And that's something that we built in our switches years ago. Because again, every time we get something good, somebody figures out some way to attack it and make attack our networks. So in this case, this guy's gone through and got an IP address. We've got 10.10.10.7 to 11.11.11.9. If they want to send information between 10.10.10.7 and 11.11.11.9 in their own network, they don't have to go through a router. It's on your local area network. It's like you printing on your printer at home. That's all it is. In the same subnet. Now we can see that. We've got logic in our brains. PCs don't. PCs don't. So in the operating system of the PC, in the IP stack, what we call the IP stack of the operating system, every PC goes through a process every time it sends anything out of the box. It goes through this little formula. It says my IP address in this case is 10.10.10.7. My subnet mask is 255.255.255.0. And it says this is my network that I'm on, and this is my node or my uniqueness in that network. It knows that. It knows that. And anybody else that I send to, I'm going to put them in here and see if they're on my network to determine how I should talk to them. If they're not on my network, I use my router because my router connects me to all other networks. I don't need to know about them, my router does. If they're on my network, I can talk directly to them and I don't need my router. It's that simple. So, in this case, let's say we have data that we want to send from 10.10.10.7 to 11.11.11.9. So I take this data, I segment this data, and I take those segments and I divide them up, and then I'm ready to put information inside of at layer 3, what do we call the envelope? A frame. A packet. A packet. We're going to put this information inside of a packet. So this packet is going to look like this. We put the data inside of it. And now we have to put our addressing on it. We're going to have a source destination. So source is going to be from 10.10.10.7 to 10.10.10.9. And now we're ready to send it. We're ready to say, how do I send this out? Where is this person located? We go to our formula. We say, this time we're sending to 10, 10, 10, 9. Is this network and this network equal? Yes, they're on my network. Just like at your house, your printer's on your local network. Your printer's there. So guess what? Now I can talk directly to this person. I do not need to use his IP address. It's important for me to know where he's at, but now I need to know his MAC address. Does your PC know everybody else's MAC address? No, certainly doesn't know it. So we have to be able to find out this person's MAC address in order to send it to them. Well, this is where, we can just ask a question. I tell Emily and Sarah all the time, I ask them about school and everything. I'll say, well, what's your teacher expect out of it? Whatever. Well, I don't know. Ask the question. Don't be afraid to ask the question. It's really important. Works in sales too, right? What's your customer? Think about this. Does your customer ever tell you what they're thinking about risk? I do a lot of RFPs. I do a lot of RFPs for customers and everything. And we put technical requirements and all this, that, and the other, and costing and all this, that, and the other. But do the customers ever tell you about the risk they feel? That's probably the one thing that salespeople miss about risk. Because customers never put them in there.
It's one of the best selling points.
One of the best selling points.
Cover their risk. And
Yeah, exactly. If you can ask them their risk, and sometimes they may not even tell you. You might have to kind of think about what do these people think about the risk. You might have to fish around for that. But if you can ask the question about it, get their risk and alleviate the risk, does it differentiate you? Absolutely. In this case, this person's got to ask a question too. All of your devices will send out a request. It'll say, I'm looking for somebody on my network who can hear me, who has got an IP address of 10.10.10.9. It's called a broadcast. A broadcast. It will broadcast out. It'll raise its hand and say, I'm asking a question to everybody here. If I have 40 other users on this one switch, it doesn't matter. Everybody's going to get it because I want somebody's information. It's called an ARP, Address Resolution Protocol. It's actually a part of all IP stacks that say if you want to know, if you think somebody's on your local network and you need their MAC address and you've never talked to them before, just ask. Just send it out. It's a broadcast. It's a special frame that goes out. It's a frame at layer 2, and the source is you. MAC address A, and you're sending out to everybody. So we have a special address called a broadcast address. Broadcast address. And it's, hey, I'm looking, it's an ARP for somebody, it's 10.10.10.9. I put a frame check sequence on that, right? So error detection can happen, and I send that out. So I stop what I'm doing, and I send that ARP out. So the ARP goes out. Hits the switch. The switch takes the ones and zeros in, reformats, makes this frame again inside of its buffer, inside of its memory. It goes to the tail end. It runs the same formula. Yeah, it's good information. If it's not, it throws it away. But it's good information. And it goes up here from one end to the other. It goes up here and says, wait a second. MAC address A is still on port 4, so I determined that you haven't moved, because people move. And he's sending this out as a broadcast. I don't send it to one person. I send it to everybody. I send it to all ports except the port it came in on the switch. So he sends it out here to all the other ports. Everybody gets it. Now, what do the other people do with it? Well, they do the same thing. Comes in, they do a FCS check, say it's over for MAC address A, it's a broadcast, it's the mail you get in your mailbox to the resident at, our friend at whatever address. They open it up and they say, oh, it's ARPing for somebody with 10.10.10.9. This router's on this network, he's got 10.10.10.1. He reads it, says, oh, it's for 10.10.10.9, not me, throws it away. But 10.10.10.9 says, oh, somebody's going to send me something. Somebody likes me, somebody's going to send me something. So what's he do? He sends an ARP reply. He sends an ARP reply. He comes back and sends an ARP reply. Now, it's not broadcast, it's unicast. He actually replies only back to you, and his ARP reply is going to be from MAC address B to MAC address A, and it's an ARP reply, because you could have many of these going out at the same time, for 10.10.10.9. You wanted 10.10.9, here I am. You got something for me, you send it to me. Puts an FCS on it and sends it out. Goes in ones and zeros, the switch takes it in its buffer, checks this, yeah, it's good, goes up here, said, well, MAC address B is still on port 6, they haven't moved, and you're sending the MAC address A. So he carries this across his fabric, his connection to this, only this port, and sends it back to this person. Now you know where 10.10.10.9 is at and how to get to them. So now you can continue on here. So this is a frame, a packet. Now you can build your frame. You take your frame, whoop, you put your packet inside of it, and you say from MAC address A to MAC address B, FCS, and you send it out, unicast. Happens millions and millions and millions of times per second on networks.